Okay, so we're looking at an arithmetic series. So a series is formed when the terms of a sequence are added. So an arithmetic series would be the sum of the terms of an arithmetic sequence, and the sum of the first n number of terms is called a partial sum. So the formula we're going to look at, so the formula that we can use, and this is for partial sum of a arithmetic series. So we have the general formula, which is A1 and AN. So the sum of the num of n, the number of terms, is n, and this is A1 plus AN divided by 2. And then we have the general alternate, which is A1 and D. And this formula is n divided by 2. And this is 2 times the first term plus n minus 1 multiplied by D. So we're going to have a look at an example. So an example. So in our book, this is example 4. And we're going to use the sum formulas. Now, we are given, okay, we have to find the sum, and we have, so find the sum, and we have 12 plus 19 plus 26 plus the missing terms, and this is up to 180. So the step 1, the first thing we need to do, so the first term, A, is 12, and we know that the last term, but we don't know what the position is going to be A to the n, and this is going to be 180. Now the common difference, we're not told, but we can look at our terms and we can actually work that out. So 12 and 19, we can see that it's plus 7, and 19 to 26 is plus 7. So we can see that our common difference is plus 7. So we have enough information to use our formula. So first of all, we're going to use our nth term formula so we can find n. So a to the n, a1 plus n minus 1 multiplied by d. And we know that the last term is 180, and this is 12, but we don't know what n is. And we know that the common difference is 7. So we're just rearranging. So we have 12, 7 times n, 7n, and minus 7. So this is 7n, and 12 minus 7 is plus 5. And I'm going to minus 5 from both sides. So this will leave me with 7n is 175, and if I divide by 7, n is 25. So we found n, and now we can actually put this into the formula. Now it doesn't matter which formula we use, so we can use either formula. So I'm going to use the sum of n is n divided by 2, 2a1 plus n minus 1 and D. So we know that n now is 25. So this is going to be S25. And n is 25, so it's 25 divided by 2. 2 times, and the first number we know is 12. So it's 2 times 12. We said that n is 25, so this is going to be 25 minus 1. And the common difference is 7, so we're multiplying by 7. So so the sum of the 25 terms. So 25 divided by 2 is 12.5, so I'll just leave it as 12.5 a second. 2 times 12 is 24. And we have, leave that a minute. So this is plus 25 minus 1 is 24. And 24 is times 7. So if we work this out, we will have 12.5 multiplied by 192. So the 25th, oh sorry, the sum of the total of the 25 terms is going to be 2,400. Okay, so we have a guided practice question. Find the sum of each arithmetic series, and for A, we're given 2 plus 4 plus 6 plus the missing terms, and the last term is 100. So we'll write down what we know. So A1 is 2, and the last term we have is 100. Now the common difference we can work out is from 2 to 4 and from 4 to 6. So the common difference is positive 2. So now we need to find the nth, to find n. So need to find n. So we're going to use the formula a to the n. So a1 plus n minus 1 times d. And if we substitute in the values, we know that the last term is 100, and a1 is 2, n we don't know, we need to find, minus 1, and then d, the common term, is 2. So 2 times n is 2n, and minus 1, so that's going to be minus 2. So we have 2n, so 2 minus 2 is just 2n, divided is 100, and if we divide by 2, so n is 50. So now we've found n, we can use our sum formula. So we can use either formula, but I'm going to use n divided by 2. 2 times a1 plus n minus 1 times d. And we know that the last term is 50, so the sum of the 50 terms, and it's going to be 50 divided by 2. And the first term we said was 2, so it's 2 times 2. And n is 50 minus 1, and this is multiplied by the common difference of 2. So 50 divided by 2 is 25, 2 times 2 is 4, 50 minus 1 is 49, and 49 times 2. So the sum, the 50th term, 25 multiplied by 102, which is 2,550. Okay, so guided practice 4B. This time we're given the number of terms 16, and the last number is 240, and the difference is 8. But we don't know the first term, so we need to find the first term. So to find the first term, so we need to find a1. So we're going to use the formula. So a to the n is a to the 1 plus n minus 1 times d. And I'm going to substitute in what I know. So I know that a to the n is 240. I know the first term, I don't know the first term, so that's a1. The number of terms is 16, so this is 16 minus 1, and the common difference is 8. So we have 16 minus 1 is 15, so that's 15 times 8. So a1 and 15 times 8 is 120. So if I minus 120 from both sides, 240 minus 120 is 120. So my first term in my sequence is 120. So I also know that A1 is 120. So I have all the information I need, so I can just use my formula. So the sum of the number of terms, n divided by 2, and that's 2a plus n minus 1 times d. So the last term that we have, 16 terms, so that's 16 divided by 2. 2 times the first term we know is 120, so that's 2 times 120. N we said is 16, so 16 minus 1, and this is multiplied by the common difference, which is 8. So 16 divided by 2 is 8. 2 times 120 is 240. And 16 minus 1, so that's 15 times 8. And if I work this out, it's 8 times 360, which, so the sum of the 16 terms is 2,880.